Previous lesson we demonstrated how to convert denary numbers into binary, and we only demonstrated a number that was less than 15, which is the biggest or the largest denary number we can make out of a 4-bit binary unit. So today we want to demonstrate how to convert a number that is greater than 15, right? A denary number greater than 15 into a binary number. So in this case we'll be using an 8-bit binary unit. So remember from the previous lesson, when we introduced this lesson, remember 8-bit binary units, right, consist of units which are 1, 2, 4, 8, 16, 32, 64 and 128. And again, for us to get these numbers, we'll be raising 2 to the power of natural counting numbers, that is from 0 to 7, because if we count from 0 to 7 we would have 8 units. So 2 to the power 0, it gives us a value 2 to the power 1 up until we reach 2 to the power 7, where we would get 128. So stay with me. Let me quickly jump into showing you how to convert a bigger number into a binary number. So watch out for the next lesson. So we've got a number like 28. So the question will say convert 28 to binary. So we want to convert 28 to binary. So this is the question. We want to convert 28 to binary. So 28 is greater than, right? 28 is greater than what? Than 15, which is the largest denary number we can make out of a 4-bit binary unit. So in this case, we want to use an 8-bit, right? We want to use an 8-bit binary unit. So you write these bits from right to left, right? If you are writing from right to left, you are simply multiplying the number by 2, multiplying the number by 2. But if you decide to write from left to right, you'll be dividing the number by 2. But I encourage you to write from left to right. So we have the first one is 1. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2, 16. 16 by 2, 32. 32 by 2, 64. 64 by 2, 128. Right? So now we have our 8 binary units. So like I demonstrated yesterday, we simply have to consider the numbers that if we add together, the units that if we add together, they give us what? 28. So in this case, 128 is greater than 28, so therefore we switch off. 64 is greater than 128, we switch off. 32 is greater than 28, we switch off. So by switching off, we are simply writing a 0. 16 is less than 28, we switch on. So 6 plus 8, it gives us what? 16 plus 8, it gives us 24. 24 is still less than 28, we switch on. And then 24 plus 4 gives us 28, right? So we switch on. And then the rest, the remainder, will simply switch off, because it will also lead up to a number that is greater than 28. So therefore, just to make your working smart, you can simply put this in a table. You can just put this in a table like this. So now 28 to binary, the answer. So therefore 28 to binary is equal to, it will be equal to 0, 0, 0. You simply take these binary values that you obtained when you did your workings. So it will be equal to 0, 0, 0, 1, 1, 1, and 0, 0. So this is 28 to binary. So now let us use the second method, which is successive division. Division by is what we do. Successive, we are simply dividing by 2. So 2 into 28, it's 14, right? Leaving a remainder of what? 0. 2 into 14, it's 7, leaving a remainder of 0. 2 into 7, it goes 3 times, leaving a remainder of 1. 2 into 3, it goes once, leaving a remainder of 1. 2 into 1, it goes 0 times, leaving a remainder of 1, right? And now, as you can see, we have reached the end of our division, but our answer should be an 8-bit binary number. But in this case, we only have 1, 2, 3, 4, 5. So we still continue dividing by 2, right? So 2 into 0 is 0, remainder 0. 2 into 0 is 0, it's 0, remainder 0. So we now have 1, 2, 3, 4, 5, 6, 7. The last one, 2 into 0 is 0, remainder 0. We now have 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So we write our answer from bottom to top. So our answer would be, so 28 to binary would be equals to 0, 0, 0, 1, 1, 1, and 0, 0, like this. So if you compare the two methods, you actually see that the answer is correct. So you can use one method and then use another method to prove whether your answer is correct. If you get the same answer on both methods, it means your answer is correct. So this is how we divide. This is how we divide by 2 to convert a Denary number that is greater than 15. Those were two methods that we can use to convert a Denary number which is greater than 15 into a binary number, right? So just to summarize, if a number is greater than 15, it means it cannot be represented using 4-bit binary, right? 4-bit binary unit. So therefore we need to consider the use of an 8-bit binary unit. Hence we used an 8-bit binary unit to convert 28 into a binary. So in the next video we are going to look at how to do the vice versa, right? Converting from binary to Denary, right? In both ways. A number greater than 15 as well as a number that is less than 15. So this is what we are going to look at in the next video. Alright, see you in the next video. Thank you.